we're back.
Yeah.
So, yeah, do you want to maybe go through the question responses?
Yeah, so finally you have quite plenty of time to think about this. So we had the question, what will be the outcome of this for loop here? And basically you have these options, different ones, and let's now see what you have thought about it. Let's go, maybe I go from, it's the easiest place to do from here, and screen. Oh yeah, we need to.
I can make that visible.
Yeah, or I do.
There we go.
Cool. And these are your thoughts. So the most of you thought that it will produce these ICE space PELLETS, and that is the correct answer. So yeah, there were quite few of you who thought that okay, we have the numbers from 0 to 10, and that is also a good guess in a sense that actually we might have also done that. But let's take a look of the question once more. So we have the for loops, and in the end. So what we are doing here indeed is that, yeah, we are iterating over a number of times using the range function, and how many times do we iterate over is the length of these letters in this word. But then what we are actually doing here is that what we are printing, we are not printing the number that we are iterating over. So we start from 0 to 10, but instead we are taking the letters one by one from this word ice pellets and printing that. So the result here. So the result indeed is the letters one by one, and as Dave said earlier, these should be actually kind of each letter should be on a new line in this answer, but it's a bit tricky to do with this polling system that we have. So instead we have these commas in between. So that is the correct answer. If we would have wanted to have this result, so having the numbers, we should have needed to print not word in square brackets I, but we should have printed only the I, so only the index, and in that case we would have ended up having something like this in the end.
And for the few people who chose the ICE, syntax error option, the point of putting a word in here that has a space in it is just to notice that a space in Python is basically treated just like any other character. We don't see anything in that place except for a gap, but as far as Python is concerned, it's just the same as any letter or number. And when you have a print statement, the total number of characters will include any spaces that are in there. So like if you do a count of ice pellets and you're thinking, well, there's only I, C, E, P, only 9 letters or something like that, or whatever it is, 10 letters, I guess. In fact, if you do count on the length of that thing, it is 11 because it does include the space as a character.
Yeah, exactly. I guess if you have any questions about these for loops, now we can still answer them. But if you're happy of what we have now went through, we can move forward to conditional statements, and Dave will tell you about those.
Yeah, so let's switch gears here. We're going to go back to the IPython console here in Spider, And we're going to talk about conditional statements, and essentially these are ways in which we can make decisions in a program. We can choose what's going to happen based on certain conditions. And so we can start with a really simple example to kind of illustrate how this works by saying something like temperature, which I'll just call temp here for the sake of not having to type out the full word. Temp is equal to 17. That would be nice if it was that warm today. I don't think it's going to get there, but that's our temperature. And we could say that if temperature, or if temp, is greater than some value, here in Finland I would guess 25 is the cutoff value we would use for saying something like this, print, it is hot. And so what we have here is the word if, and then some kind of comparison or some kind of calculation that's done to check two values relative to one another. And then if this condition is met, we're going to print it is hot. And if that condition is not met, we have this else, then we're going to say print it is not hot. And so you can look at this and probably already see what's going to happen when we run the code here. We've defined temp, it's 17. We're going to go here and say, is temperature or temp greater than 25? Well, no, that's not true. So we're going to go down to this else statement and do what that says to do. And so when you hit enter, you see it print out, it is not hot. So, the idea logically here, I think, is fairly straightforward. If you meet the condition you have here, then you execute the lines of code that are indented underneath that if statement. If you don't meet this condition, you go down here to the else, and you then execute the commands that are listed, again, indented, just like a for loop, beneath the else statement. So we see here, it is not hot. And I guess, to me at least, the idea is fairly intuitive. If you look at the lesson for this conditional statement stuff on the course page, you'll see there is a little note here about how we basically operate already using conditional statements every day, although we don't call them necessarily conditional statements when you think about it. But if you think about when you get ready to go out for the first time, many days, especially this time of year, you're probably going to take a look outside and make a decision. Do I need to wear a rain jacket or not? And so you look outside, you make an assessment, it's raining. So here we could say, for instance, the weather is equal to rain. And then logically you would say, okay, well, if it's raining, then I will wear a raincoat. If it's not raining, then no raincoat is needed. You do this stuff all the time. And whenever you have, this word conditional statements used in one of the exercises or somewhere else in the course, you should kind of think about, okay, I need to make a decision, just like any decision I make. If I'm hungry, then go eat food. Otherwise, don't go eat food. This stuff is, basically how people operate all the time. We're just going to use the same ideas within a program in Python. And so in some respects, we're learning something new in terms of how to talk to the computer to do these decisions, but we're not learning anything new in terms of how we tend to operate most of the time. So that's what we're going to do and talk about here for just a little bit here with these conditional statements. As it turns out, if we redefine our temperature here to be maybe equal to 13, we can go and again do another if test. So if temp is greater than 25, and we're going to print out, if this is true, that 13 is greater than 25. And with this, we don't always have to have an else condition in using these if statements. You can have an if statement that is just testing to see whether something is true and doing some action if that thing is true, and doing nothing if it's not true. So here, with our if statement, when I press enter, we see, of course, because 13 is not greater than 25, that nothing happens. So we've given a print statement to execute if that condition is true. It's not, and so nothing happens. We could modify this by, for instance, saying, instead of temperature being 13, temperature could be 31, and you could do the same thing. Oops. Like that, and of course 31 is greater than 25, and so that does get printed to the screen in that case. The point here is that you don't need the else statement to be there. There are lots of times in programs where you want to do something special only if one condition is true. So for instance, if you're reading in data from a file, if you haven't read the data file yet, you want to read it before you process the data. If the data has already been read in, then you don't do anything. Okay, so I suppose that's relatively clear so far. Let's try another example. Here now we're going to set temp equal to a winter temperature, -3. And what we can say with a slight modification of our conditional statement is we'll have if temp is greater than 0, we'll print that, maybe we'll do it this way, temp is above freezing. So here I've given temp outside of the quotation marks, and then in quotation marks is above freezing. Here's something we haven't seen yet, and that is something that's called an else if statement. So we have an if statement that says, is something true, then do some action. We can also have a follow-up that's an else if, where we say, okay, if some other condition is true, do something else. So here it's called elif in Python, just as a shortening of else if. But here we could say print, our condition would be temp equals 0. So if the temperature is exactly equal to 0, then we print that temp is freezing. And finally, then we can also have an else statement at the end. So if it's not above 0 and it's not exactly equal to 0, in all the other cases, we're going to do the following, which is to print that temp is below freezing. So before we run this thing, we've set our temperature to be -3. We're going to check, okay, is it greater than 0? No, so this won't happen. Is it equal to 0? No, so this won't happen. And then what we're left with is the kind of garbage collector, the else statement at the end that says, okay, if nothing else has happened, then fine, we'll do this last thing, which is to say that temp is below freezing. And of course, when you hit enter, then you see exactly that. -3 is below freezing. If you want, you can go and set temp equal to 0 and go through and find that 0 is freezing. And if you set it to some positive value, of course, this works just as well. You see that 4 is above freezing. And again, I'm just pushing the up arrow to kind of get back to what I've already typed in. One thing that's maybe worth noting about these commands, when you type them in the IPython console, you'll see that it nicely does the indentation for you. That's helpful. When it sees you've typed an if or a for, it will automatically put in the 4 spaces at the start of the next line. But if you go up here and, for instance, if you can see the cursor, my well, I don't know what this thing's called, whatever, the blinking little thing that says where I'm typing in the text, is currently after if temp is greater than 0. And I have this other stuff that's typed underneath here. If I hit enter, it starts putting in blank lines in between there. So if you have problems that you've started, pressing enter in the middle of some statement, you can just press the down key until you get to the bottom, or you can also hit backspace to kind of put things back onto one line. Like if I put the cursor here and hit enter in the middle of this is freezing, I can hit backspace to kind of fix that and then go and get to the end of this thing and type that in. Sometimes you have problems with that in the IPython console, that you just hit enter in the middle of a line or something like that, and you can get kind of unexpected behavior that way. So that's not super important, but if you have this issue in the IPython console when you're pushing up and down to kind of go to previous commands, sometimes that'll happen. All right, so I guess so far so good as far as these if statements go. The format's very similar to for loops in the sense that you have the if and then intended stuff underneath it. The difference is here that we have a test of some condition to see whether something is a true or false thing. And so, this temp greater than 0, if we have temp, we see it's here. If I just type in the IPython console temp greater than 0, do you have any idea what's going to happen? What it's going to return to the... Yeah, so someone said true up there. If you hit enter, it returns a Boolean variable, a true or false statement. So then if I say the opposite, if temp is less than 0, of course I get false. So what you can see with these conditions is they either evaluate to be true or to be false, and that determines, based on the if, elif, and else, how the program will proceed. So it should be a true or false kind of thing there. A common mistake might be to say if temp equals 1, and you're going to get a syntax error if you try to type this into the IPython console, because temp equals 1, as shown here, is an attempt to assign a number to the variable temperature. It's not checking to see if the value of temperature is equal to 1. It's trying to assign it because there's a single equal sign there. If you want to compare, again, if something's exactly equal to a value, you have to put in 2 equal signs as the way of doing the test of are these 2 values exactly equal to one another. If you do that, then you can, get your normal print temp is equal to 1. And that's going to print nothing because temp is not equal to 1 right now. So these comparison things, we see here the exactly equals to is with an equals sign, and in the lesson there's a little table. I'll just show it here, maybe briefly. We have this table here of the comparison operators you can use in Python. So less than and greater than, I guess those are probably familiar to you. Less than or equal to is just the same kind of less than followed by an equal sign, and same thing about greater than or equal to is just the greater than plus an equal sign. Here we have the exactly equal to, and the other one sometimes you'll want to use is to check to see whether a number is not equal to another one. If we have some time at the end of the lecture today, maybe I'll show you some fun things you can do with the not equals test about figuring out how big or small of a number your computer can represent. It's kind of a nice little thing to do in Python. But for the moment, let's shift our attention here to check on how well you guys are understanding these logical ideas that you use with conditional statements. So we see, for instance, that yesterday it was 14, it's 10 outside today, and tomorrow it's going to be 13. These are probably not the right numbers, but they might be as close as the FMI gets on a daily basis. And the following code here is going to basically compare some of these numbers and do different things based on the comparisons. So here we define our temperatures, yesterday, today, and tomorrow, as the numbers we just mentioned. And then we have a series of if, elif, well, I guess it's just if and elif statements that will print out the letter A if yesterday was less than or equal to today, the letter B if today is not equal to tomorrow, etc. The question for you is which one of these letters A, B, C, and D would be printed to the screen when this piece of code is executed. And for this, we have a poll question, so I'll put that up on the polling page. And you can look through here. Again, I'd like you to mainly think through this rather than just copy and paste it into your spider. But you can go through, take a moment to think of which of these things, when compared with one another, would be true or false, and which letters would then be printed to the screen. And we'll come back to this after just a few minutes. So there you have your choices, as you should see for the poll in front of you as well. Some kind of quiz or something. Analog. So maybe just one more minute here. Let's see, we've got about 21 responses, so we got 23 with the last poll, so maybe a few more people could answer if they would like. You can see someone having fun clicking all the different buttons. All right, so let's take a look at the responses here. We've got 22 in total, and the overwhelming majority here have chosen B, C, and D. A few choices for some other combination, and a few have chosen B and D. So let's take a look. If it's B, C, and D that seems to be the popular choice, let's take a look. So if yesterday is less than today, so we're going to have the number here for yesterday, 14, less than or equal to 10, of course that's false, so A would not be printed. If today is not equal to tomorrow, so if 10 is not equal to 13, that should be true. So we would expect to see B printed to the screen. If yesterday is greater than tomorrow, so yesterday was 14, tomorrow is 13, so 14 is greater than 13, that's also true. So we have B and C so far. And then if today is exactly equal to today, that is going to always be true no matter what value you put into today, as far as I know. I think even if you set today equal to false, that will still evaluate to be true because false is equal to false. You can play around with these kind of things if you like to learn some logic in Python. So it looks like D would be true as well, and so B, C, and D would be what we would expect to see printed to the screen if we ran this code. In fact, we can, because it's easy to do, copy it and just paste it into the IPython console. And we get B. Why do we only get B? It's because the else if is only going to execute the first one that's true. Yeah. Okay, so someone out there who chose some other combination was actually spot on about that, because you're right. With this, the first thing that's true in a series of these if statements is the only one that will be executed, and the others will be skipped.
And that is a good lesson to learn.
Yeah, you've taught us something about how we write our questions here. So, in fact, some other combination is the correct solution here. Logically, B, C, and D all would be printed if they were individually done with separate if statements. If given as one if statement, that's exactly right that we only get one of these printed out. So, nice work to those of you who thought through how this actually would work when you run it in Python instead of...
Maybe if you show how would we end up having the answer that we thought.
Yeah. So, if we were to take the same thing, basically what we would have to do is do all of our comparisons individually. In order to get this to work, we'd have to have separate if statements. So we have yesterday, today, and tomorrow already defined. And what we would need to do is take our if statement here. And this isn't going to copy and paste nicely, I don't think. Maybe it will. So we evaluate the first if statement if yesterday is less than or equal to today.
What if you change the else to if in that iteration?
Yeah, you could do it that way too, right? So we could just take the, if we didn't want to copy and paste, again, because the if statements will only do what is beneath them, you could just change the elifs to if. And if we type, where did it go? If we type this one in and hit enter, then we get our B, C, and D as expected. So, yeah, I think I borrowed this from some other exercise I found online, so maybe they had a mistake too. I'm not going to take the blame for this.
Excuses.
So, no, I probably screwed up doing this. Obviously, you can see how well I tested it by copying and pasting it into Python for the first time here. But the point is that logically, the idea is to check and see whether you get, are these statements true or false, and the code executing different parts based on whether something is evaluated as true or false. So, but this turned out to be maybe a better illustration than we expected as a result of the mistake. So.
What do you think, in a normal case, why wouldn't you use this kind of approach typically when you think of finding and having some kind of criteria? So having multiple if lines, so we are actually testing is this true, is this true, is this true? So basically what I try to ask, what is the benefit of doing it this way compared to this? You just saw a perfect example of what is the actual difference here.
Slide it to the computer.
Yeah. So why in a typical world, so usually when we are trying to find and for example here find the correct answer, you don't need to actually find all the solutions. You just want to find one kind of that if this criteria is met, do this, and other cases you don't even need to actually check. So we are kind of reducing the amount of work that computer needs to do. So this basically the example that we just gave you is basically saying that whenever, so it checks first this, and if this is not true, it goes to the second criteria, and if this is not true, it goes to the third one. But if this is true, it doesn't actually need to go to the later parts, because it already achieved the thing that was wanted. So that is the kind of logic behind, and it can kind of, using the elif statements can reduce a lot of work that computer needs to do to find the criteria in this case, and find the solution. So that's kind of an important thing to kind of understand, that if you have elif, then the first thing that is true will be the final result as seen in the example here. So just one thing to understand.
And the other thing that's probably somewhat clear here is, normally when you have a series of if and elif statements following one another, you're comparing the same type of thing in each subsequent statement. So if we did the example of temperature, we check first to see if temperature is above 0, then if it's equal to 0, and otherwise we know it's below 0. In each case, we're comparing temperature. Here, we're basically doing different comparisons that are somewhat arbitrary. So having it written in this way of if, elif, it doesn't even necessarily make any sense from the perspective of the program, because these things don't necessarily depend on one another. If something is true, it doesn't mean, like for instance here, if yesterday's temperature is less than or equal to today's temperature, it doesn't really have any relationship whether today's temperature is not equal to tomorrow's. So we might, in other cases, want to check, okay, well, if it's less than or equal to today's temperature, then maybe we want to say, if that's not the case, maybe we want to check about something with the temperature, since we know it should be positive, being greater than some value or something like that. Normally these things would relate to one another, as we'll see in other examples in the exercises and things like that. So yeah, we can perhaps continue from here and take a look at one other thing related to conditional statements before Henrik gives a little bit of an overview of the exercise 3. So when we do these conditional statements, what we've seen so far is you check to see if one comparison is true or false. But we can actually use more than one comparison with a single if statement as well. For very simple illustration, we can do it this way. So we could say if, and then I'm going to use parentheses here in this case, because this is the way in which you do multiple comparisons, is you put the things in parentheses. So if we say if 1 is greater than 0, 1 is greater than 0, and minus 1 is less than 0. So here we're going to do one test and then a second test. If both of those things are true, then we want to do something. We're going to print, I guess in this case, both are true. Now, if we know both things are true, in that case, if this statement is false, then we would print that at least 1 is false. We don't know whether one or both of those things is false in this case. 1 is greater than 0, that's true. Minus 1 is less than 0, that's true. So in this case, we expect to see both are true printed to the screen. And if we hit enter, sure enough, we see both are true. If we take the same thing here and change one of these comparisons, so if 1 is greater than 0 and minus 1 is greater than 0, well, this isn't true anymore. So this is a logical and. So for those of you who know a little bit about logic, it combines two things that are true and returns true. If one of the two is not false, it returns false. And if both are false, it returns false. So here we have minus 1 is greater than 0, that's false. So now we expect to see at least one is false printed to the screen. We can take the same thing that we've just typed in and make a slight modification. So we have here 1 is greater than 0, minus 1 is greater than 0, but instead of and, we could say or. So in that case, if one of the two things is true, then we expect to see not both are true, but at least one is true. Again, with an or, we don't know whether one or both of the things are true, but at least one of them has to be true in order for this thing to get printed out. What we can say is that if neither one of these things are true, that's the only time we'll get down to this else statement here. So we would know here that neither is true. Now, this kind of logic, to me at least, is basically burned into my existence. But I do understand that for you, perhaps it's a little bit confusing at first to think about how these things combine together. I guess we should probably at some point put a little table in the lesson that just shows how and or combinations work, just to show that if two things are true, that's the only time an and statement will give true, and for an or, the only time you'll get false is if both things come back as false. So here we see when we do this 1 greater than 0, that's true, minus 1 greater than 0, that's false, but we still get this statement here because one of the two is true. If we modified it and said that minus 1 is greater than 0 and minus 2 is greater than 0 instead of 1 is greater than 0, in this case, what we now get is that neither are true. So this is false and that's false, which means that we end up down here. One of the two or both has to be true in order for that top line to be executed. And again, well, maybe I'll just take a second. Is this confusing or somewhat clear in terms of the logic of these things? At this point, we're starting to get a little bit more complicated in terms of the logical comparisons. We're comparing two numbers, but then we're also checking to see whether those, one comparison is true and comparing it to another one to see whether it's true and making a decision about what the code does from that point. Is that sort of clear to you? Or, I mean, it's sometimes hard for me to tell. I see most people kind of nodding. We'll get some practice with that in the exercise this week, so that's good news for you, maybe. Yeah. The one thing I did want to show here about the conditional statements, though, is again that this is something we do every day when we do these kind of comparisons and combining the what we observe in different comparisons. So let's say now that not only do we care about whether it's windy or whether it's raining, but we also can consider whether it's windy outside in terms of what clothing you want to put on. And here's the situation. If it's raining and windy, you basically just don't want to go out at all. It's not worth it. So here, the unfortunate circumstance have manifested themselves. It's weather is rain and wind is windy. Now, what we could say is that if it's raining, so if the weather is equal to rain, and if it's windy, the wind is equal to windy, then print just stay home. We're going to write a Python script that will make this decision for us and tell us just stay home. Otherwise, if the weather's rainy, well, then in that case, all we need to do is just wear a raincoat. And in the case that it's not rainy and it's not windy, then no raincoat is needed. In fact, actually here, it could be windy, but as long as it's not raining, then no raincoat is needed. So let's take this thing for a second here. This will probably not paste nicely into IPython. So I'm going to paste it over here in the spider editor and just clean it up for a second. Get rid of these things at the start of the line. And that's not indented the right amount. just format this quickly, oops, so that we can play around with it. Now I'm going to copy and paste this out of here into the IPython terminal. So what we see is the weather, just like we saw, is rain, wind is windy, and we have our comparisons. And what we see printed out to the screen when it's rain and windy is that we should just stay home. If we want to change the weather conditions, for instance, we could say weather is sunny, but the wind is still windy. What's going to happen here? What do we expect to see for what's printed to the screen? Any ideas? So the else statement here at the bottom, right? We compare first if it's rainy and windy. It's not. Then we say, is it rainy? It's not. And so what we're left with is the else statement at the end that says no raincoat needed. That's what we expect. And sure enough, that's what we get. Just for the sake of completeness, we could say that it is rain for the weather, but the wind is calm. In this case, again, what do we expect to see here? Exactly. So you can see how these things, combining sometimes one comparison with another comparison, you can come up with slightly complicated logic, but you can also allow yourself to make some pretty interesting decisions in how the code operates. And this is, again, just kind of a simple example. When we talk about conditional statements, when you think about the logic, hopefully you'll kind of have the picture in your mind come back to like choosing the clothes that you're going to wear when you go outside on a given day. And there are, this was the first example that came to mind when I was coming up with everyday examples, but there are hundreds of them that you could come up with where you use this kind of logic every single day. Conditional statements are basically life for us. So with that, I'll ask, are there any remaining questions about conditional statements or anything that we've done? Because if not, I think Henry will give a quick overview of the exercise for this week, and I guess maybe I will pull this up for you to make that a bit easier. Yep.
Okay, so this week, as said, so what we are going to do is that we really start practicing doing for loops and conditional statements ourselves. There are altogether, actually, this week 5 kind of problems, but don't worry, the first one is really kind of easy to do. So how we give you points when we are doing the gradings and so on. So basically we want you to accept a classroom. So we basically will have individual repository for each one of you where we will update when we continue with the course the points that you have gotten from exercise 2, 3, 4 and so on. So there is basically a single place where you can always go and check what you have gotten from different exercises. So the first problem 0 is basically only that you just accept and make the repository for yourself. But then the actual content, so the problem 1, so that is kind of a problem that is something really common when we are doing programming and doing data analysis. So you are quite often having these kind of situations where you have let's say a set of data, 1 million rows, for example, about species distributions or something like temperatures in different places, and you have the data is so big that you actually don't want to analyze it as one large chunk of data. Instead, you actually want to separate it into different files. So this problem number 1 kind of gives you an example, and you can try to make those output file names. So think this as an example and a task for you to kind of create some kind of output name. So in this case, we are working with the station names, so the weather stations in Finland, and we have this. We want to have these kind of file names. So we want to have station 0.txt, station 1.txt. So basically file names with this continuous numbering in the end. So that would be basically those kind of output files where the data has been separated to different stations. So what you need to do here is to basically iterate over the numbers from 0 to 20, then use these different variables to combine and produce a text like this. And basically in the end we want you to have this list of these file names, and in the end you should end up having something like this. So it should be quite straightforward task to do, the first one. And there are criteria, basically how you are created in this one. Then the second problem goes into more of our weather and climate and temperature kind of theme that we have throughout the first period. So the problem 2 is focusing on basically classifying temperatures to different kind of comfortable zones or so on. So basically we have in this script classify temperatures that looks like something like this. So we have this kind of starter script. So inside this script you have this kind of list of values that are temperatures separated into nighttime, daytime and evening time temperatures basically, and they are temperatures from Helsinki Malmi Airport Station. So what in this exercise we want you to do is to basically classify those temperatures into these different classes. So we want you to check if the temperature is less than -2 degrees, so basically that would be cold. If it's between -2 to +2 degrees, it's more or less, usually it might be quite slippery at that point. Comfortable in this case goes from +2 to +15, and warm goes +15. Well, we are in Finland, so we don't have that warm weather here, so we think that +15 is already okay. So basically we want you to do this kind of classification. So you need to basically use the for loops and do the conditional statements to actually figure out and classify these into different lists. And basically all of these different comfort zones should be in a separate lists, and then you kind of append into those ones. So that's the basically problem number 2. There is also an extra task specified in here. So basically the things that I just told you was the things that you should do, but for someone who wants a bit more challenge is that there's this extra task where you should basically separate these morning, evening and nighttime values into separate lists, and then basically calculate the mean average daytime temperature, and basically give answer to that. So for those who want more challenge, there is that extra, but it's totally optional, so you don't need to do that, and it's not affecting your grade or points. Then the number 3, the problem 3, kind of continues the same logic, but in this case we are working with weather stations. So this map basically shows you the locations of Finnish weather stations that are older than 70 years old. So basically what we want to do is that we have now divided Finland into 4 these kind of geographical zones, so northwest, northeast, southwest, southeast. And what we want you to do is that basically you should check how many or what are the station names in each of these geographical zones that we have here. And basically the data, so again we have this starter script that looks like this, and they are basically each step that you need to do is written in here, so you can kind of try to follow those. But basically what you have there is that you have 3 lists. So you have one list that has the names of those stations. So for example, here we have eight stations and the names are here. So the first one is Hanko-Russarö. Then we have a second list that has the latitude coordinates of that station. So Hanko-Russarö, so latitude would be 59.77. So basically the index 0 always kind of determines the values for that one station. So Hanko has latitude 59.77 and longitude 22.95. So these kind of belong together. So what we want you to do is that basically you need to kind of figure out a way how you can specify using those coordinates that we have here that to which geographical zone does that station belong. And when you know the answer, we want you to basically give the name or insert the name of that station into corresponding list. So basically you should have 4 lists. So you have one list for northwest, northeast, this should be actually southwest and southeast. And then you do the criteria and add the station names to those lists. And in the end we want you to print out the names in different zones. Yeah, so that's the idea of that problem. There is also an optional task. So basically the last step there would be to calculate and print the share of stations at each geographical zone. So basically the idea is that we could assess if the network of weather stations is more or less equal in different parts of Finland. Of course we can already see from this map that it really isn't equally distributed in different parts, but doing this programming we can actually specify how they are distributed in different parts. Yeah, so those 3 are the problems for this week. There is an extra problem from last year that was quite interesting and challenging for quite many. So this is something extra that if you want to do. But here we kind of introduce you to an idea of having these kind of nested loops. So inside one loop you have another loop, and then you can produce these kind of information. And the task here is to produce this kind of map, or flag, sorry. So you should produce a flag of United States using 4 loops and using just 2 characters, using this kind of star character and dash, and that's kind of a bit more trickier question for you to try to solve. So that's the exercise this week. And if you have, by the way, there is also the hints. So there is a link and there are the hints for doing stuff. So there is also information about nested if statements that can be handy in some occasions like our exercise. So check those if you run into troubles. Yeah, but see you next week or tomorrow and Friday.